Very good morning, friends. Today we will see the very last topic in our engineering mechanics, that is in collision of elastic bodies. Collision of elastic bodies. You can see if two bodies collide each other, there will be an impact between the two bodies, right? So this is called line of impact, and normal to this, if you draw the two bodies where it is collide, that is called plane of contacting surfaces. So first of all, we should know what is impact. Impact is nothing but if the collision between the two bodies occurs in a short interval of time. The collision between the two bodies occurs in a short interval of time, during which a large amount of force is exerted in between the colliding bodies each other. That is called impact. So, line of impact. What is line of impact? Line of impact is nothing but a common normal to the plane of contacting surfaces. Plane of contacting surfaces is this. Common normal is to that is called line of impact between the two bodies, the colliding bodies. Then what are all the types of impact available that we should know? So in types of impact, this is first impact is central impact. Central impact is nothing but two bodies, colliding bodies. If the mass centers are lying on the line of impact, then it is called central impact. So central impact, you can see if the two mass centers of the colliding bodies lies on the line of impact, then it is called central impact. Then the second impact is called type of impact is eccentric impact. Eccentric is what is that? It is if the mass centers are eccentric to the line of impact, then it is called eccentric impact. You can see in the diagram, if the mass centers are not falling on the line of impact, then it is called eccentric impact. Then two more impacts are called direct impact and oblique impact. Direct impact, you can see the line of impact is the two bodies are colliding. If the motion of the two bodies are directed along the line of impact, then it is called direct impact. If the motion of the two bodies directed along the line of impact, then it is called direct impact. If the motion of two bodies are not directed along the line of impact, then it is called oblique impact. So you can see the velocity and the velocity of the body body B is in a different inclined manner, it is colliding, that is called oblique impact. So this is about the introduction of impact and impact of elastic bodies. Then in this we will see how to solve the impact of elastic bodies problems. So we will see, for that we should know two equations. The very first one is, you can see the situations of impact, collision. So body A having a mass of m1, body B is having a mass of m2. It is moving in a velocity, two bodies are moving in a velocity u1 and u2. That is their initial velocities. So here, when the collision occurs, if u1 is greater than u2, if this is greater, it will go and collide with u2, m body 2, right? So the collision occurs, there will be a collision takes place, there will be some time, it will collide and it will start restitute, separate, and it will start separate. There, while separating, it will be having velocity, final velocity v1 and v2. Here, in this situation, after separation, the velocity of 2 will be more, velocity of 1 will be less. So, separation velocity will be v2 will be greater than v1. Final velocity v2 will be greater than v1. So, you should know one thing. What is the coefficient of restitution? Restitution coefficient. That is nothing but relative velocity of separation by relative velocity of approach. It is the ratio between relative velocity of separation by relative velocity of approach. So, this is the velocity of separation. This is the velocity of approach. What is the relative velocity of separation? Which is bigger? V2 is bigger. So V2 minus V1, that is going to be my relative velocity of separation, and divided by relative velocity of approach. In this initial velocity, which is bigger, u1 is bigger, so u1 minus u2. You have to mark this equation, that is eccentric coefficient of restitution will be E will be equal to V2 minus V1 by the same one, U1 minus U2. V2 minus V1 by U1 minus U2. So for perfectly plastic, if it is plastic, the coefficient of restitution will be 0, that you should know. If perfectly elastic body, the coefficient of restitution will be 1, exactly it is 1, since it is perfectly elastic body. So in between bodies there will be variation from 0 to 1, you will be having the coefficient of restitution. Then to solve these kind of impact of elastic bodies, you should know the another equation, that is conservation of momentum of bodies. So momentum of each body will be conserved before collision and after collision. That you should know. Before collision, what is the momentum of each body? That is m1 u1. Momentum, you know, mass into velocity is nothing but momentum. So m1 u1 plus m2 u2 is the before collision, the momentum. m1 v1 plus m2 v2 is after collision, the momentum of the two bodies. So both are equal. That is my second equation. Using the coefficient of restitution equation and conservation of momentum equation, we will be solving problem in the next video. Thank you.